Welcome back to STS. In today's video, we're working with a system of linear equations. We're going to use the elimination method to figure out where these two lines actually intersect. With the elimination method, we have to decide to either eliminate the x variables or to eliminate the y variables. We're going to start by eliminating the x variables. So what we're going to do is take the second equation and we're going to multiply through by a 2. So if I were to do that, I have 2 times negative x to give me a negative 2x, 2 times 3, y to give me a 6y, and then 2 times 4 to give me an 8. And what I'm going to do now is take this first equation and rewrite it underneath. So here I have 2x plus 4y is equal to 12. Now at this point I'm going to add these two equations together. So negative 2x plus 2x, that goes away. Then I'm left with 10y is equal to 8 plus 12, which is 20. Notice how we just eliminated the x variable. Now we solve for y, so we divide both sides by 10. And here we see that y comes out to have a value of 2. And then we take this value for y and substitute it back into either equation. Let's substitute it back into the first equation. So here we have 2 times x plus 4 times y. Well, y is a 2, and that should equal 12. Then we begin to resolve 2x plus 4 times 2, which is 8. Rewrite the rest of the equation. Now let's subtract 8 from both sides to get the x variable by itself. Those cancel, and I'm left with 2x is equal to 12 minus 8, which is 4. And to get the x by itself, we divide everything by 2. And we come out with x being 2. So our solution here is 2, 2. Alright, let's do this let's use the same method again. And we're going to use the same method to actually solve for, or actually to eliminate the y variable. Alright, let's just rewrite both of the equations again. So we have 2x plus 4y is equal to 12, and then negative x plus 3y is equal to 4. Well, to get rid of this y, I need to have the coefficient needs to be the same, except for one has to be positive and one has to be negative. To do that, I see the easiest way is to make both of these 12. So one has to be a positive 12, the other has to be a negative 12. So what I'm going to do is I'm going to multiply the first equation by a positive 3. And I'm going to multiply the second equation by a negative 4. And then let's distribute these constants through each equation. Well, 3 times 2x gives me 6x, plus 3 times 4y to give me 12y, and then 3 times 12 to give me 36. Then for my second equation, negative 4 times negative x gives me a positive 4x. Negative 4 times 3y gives me a negative 12y. And then negative 4 times a positive 4 gives me a negative 16. Notice these 12s are going to cancel. The positive 12 and the negative 12 cancel out, eliminating the y just like I want. Now I have 6x plus 4x to give me 10x. And on the right hand side, 36 minus 16 to give me 20. Divide both sides by 10. And I'm left with x is equal to 2. And I take this value of 2 and I'm going to substitute it back into one of these original equations. Just to be different, or different from the first example, I'm going to substitute it into the second equation. So I have negative x, well, x is a 2, plus 3y is equal to 4. And now I evaluate negative times 2 to give me a negative 2, plus 3y to give me, plus 3y equals 4. And then I'm going to add 2 to both sides to eliminate the negative 2 and the positive 2. So here I have 3y is equal to 4 plus 2, which is 6. Divide both sides by 3 to eliminate this coefficient of 3. And here I see y is equal to 6 divided by 3, or 6/3, which in fact simplifies down to 2. And again, we see that our solution comes out to be the same. Our intersection is still at the position 2, 2. Alright, so that's it for this video by Speller Tutorial Services. Please friend us on Facebook and also subscribe to that YouTube channel. And as always, Thank you for watching.